Okay, now
Yeah.
so is this visible to you? Is this visible?
Visible now.
I can't hear
It
you.
is visible now.
Yes. Okay. So we were going to discuss about differentiation, the concept of what is differentiation. So so can you still listen to me? Can you still hear me?
Yeah, yeah, I can hear you.
Okay. So first of all, we have to understand the concept of slope. What is a slope? So the definition of slope, if you mostly if you watch videos from US YouTubers, they will give the definition of a slope as rise over run. Rise over run. This is the slow definition of slope. So this is how it is. So
What is this two term mean?
what did you say?
What is the terms mean? The rise and the run.
Rise over run. Suppose let me tell you. Suppose this is for first of all in the last failed video I discussed that uh, why is it not changing? I can switch back to the video. Oh, I think I, I can't change it to the pen. It's stuck on the eraser. I'll try my
Can
other,
you not can you not click on draw?
but now everything is gone. I will I'll use the other app. Okay, you can see this one.
Yeah.
Okay, I'll just use this one now. Okay, so as for this kind of line, there is no slope. Unless the slope is zero. Slope exists, but the slope is zero. So for this kind of line, which has a slight tilt, so this line has a slope. By rise over run, I mean that this is what we mean by the slope. For actually, the slope is calculated between any 2 points. But for a straight
Okay.
line, for any 2 points, it will be same. But if you look at a curve or some other kind of lines, other kind of uh, yes, what could you say? Other kind of functions, it may be different
Yeah.
from point to point. But for straight line, the slope between these 2 points will be the same as the slope between these 2 points. So the slope is this term divided by this term. Suppose this point has a coordinate. Suppose x1 and y1. This point has another coordinate x2 and y2. So I mentioned that slope is described as rise over run. So rise means this one. From this point to this point, how much it has risen. We can find it by measuring this distance. And this distance can be measured as y2 minus y1. And run means how much horizontal distance it has covered in from this point to this point. It's this distance, and you can get it by x2 minus x1. So is this clear so far?
Yeah, it's clear.
Okay, so this is what a slope is, or is. So the whole point of, but okay, before coming to calculus differentiation analysis, this is also the definition of, you can say this is the definition of average, you can say. So consider another line. Suppose this is another line. Let me use another color. Suppose this is another line.
Yeah.
And if you are asked to find the slope between point x1 between these 2 points, x1 y1 and x2 y2, for these 2 points, the slope of
Yeah.
this red line and this straight line will be the same. Can you understand this?
Yeah. So it just calculates. I understand, but
Okay,
I don't know how to explain it.
okay. Now, in the I'll take the given example. So instead of going through it theoretically, I'll just try to give an example. I'll solve everything with an example, and I'll take the example of a car and its speed and velocity. Okay, let me take the x-axis as time. Okay, and the y-axis as the distance. Okay,
Yeah.
and what is the definition of velocity? Velocity is distance divided by time, isn't it? Do you remember this formula?
Yeah. I remember.
Okay, so suppose this straight line denotes the distance traveled by a car. Okay, and since this is a linear, I would say the line is a straight line. You can say that the car is moving at a constant velocity. So that is why for
Right.
each time it is going at it is covering equal amounts of time. And but the other one, the one with the red line, it's not going at a constant velocity. It is accelerating at some point, decelerating at some point. So you can see that the distance it covers between each time frame is different.
Yeah.
Okay, so but regardless of this, between time, suppose instead of now considering x1 and x2, let us take this one as time t1 and time t2. Okay, suppose this is 1 p.m. and suppose this is 2 p.m. The average distance covered, this is the y2 minus 1, is the same. This one here, speed may be different between this time frame, but overall it balances out. So means I think so you are getting the idea what I'm trying to say.
Yeah. I understood.
Can you hear me? Or
Yeah. I can hear. Yeah. I understood.
okay, okay. So this is the concept of a slope and yes, okay. Now in case of differentiation or yes, what we're trying to do is we're trying to reduce this distance, this t1 minus t2. Suppose we have another graph, and instead of finding the average, this is another graph which in the axis we have time and in the y axis we have distance. And instead of trying to find the velocity between two big time frames, we are trying to find out the instantaneous velocity. Suppose we are trying to ask what is the velocity at this point. So essentially what we're trying to do is this distance, we're trying to narrow it down. So we're trying to bring this line very close, very close.
Yeah. So we're trying to find the slope of between 2 points, but the 2 points are very close.
Yes, so it is essentially a kind of a tangent. Suppose in this point, suppose we're trying to find the velocity here. So essentially this is a tangent. We're trying to find this line.
Yeah.
So this line will change at every instant. Suppose in this instant the line will be this instant the line will be this. So this is what we are trying to do. Okay, and
Isn't? Oh, I think I remember some hearing somewhere that differentiation is finding out the rate of change. Is it something like that?
yes, it is all about the rate of change. It is all about the rate of change. Because the rate of change, suppose
Yeah.
this slope is increasing here. So the rate of change of velocity or the rate of change of distance
Yeah.
with respect to time is high in this area and it is low in this
Yeah.
area. That is changing. The rate of change is the rate of change is changing. The rate is high in some points, it is low in some other points. So let me just go with show this formula a bit more mathematically. So velocity. So okay, distance. So instead of velocity, now okay, let me just try to start with here again. Start fresh again, and I'll just try to show the formula with how this the formula of differentiation comes out. Suppose this is the line, and we are trying to find out the velocity between time t1 and time t2, where it has distance. Suppose we denote distance by s1, s2. So velocity is equal to, so rise over run. Again, the formula of rise over run, t2 minus t1. In case of differentiation, this line is this t1 and t2. This time period, we are trying to reduce it very much. So we can rewrite t2 as, we'll write t2 as t1 plus h. Okay,
Okay. Yeah.
and uh, this s1 and s2, we have s1 and s2, and we can say that you might know that this in this case x is the independent variable and y is the dependent variable. So we can write y as a function of x. So y, the distance is changing with respect to time, means that the time is influencing the distance. The time goes independent of the distance.
Yeah.
Okay, so this is how we're going to write, not ft. So here we can rewrite this equation as this. T2 will write it as T1 plus H, because we have written T2 as T1 plus H, and T1 will be the same as T1. And S2 will write as a function of F, yes, F T1 plus H and FT2. Did you understand how I got this one? FT and
Yeah. I
FT.
understand this.
Okay, so this is velocity, but this is the instantaneous velocity. So instead of V, here we have used V, here we'll use dV. dV is this s2 minus s1, you can write it as delta s, like the change of speed and yes, yeah, not speed, change in distance by change in time. So when we use instantaneous velocity, we write yes, when we refer to instantaneous change in time and instantaneous change in distance, instead of delta, we'll use d. We are going to change it to ds by dt, and we'll write, okay, just uh, I need some space here. Okay, we'll like also put this to be limit h tends to 0. So
What
there
is this limit h tends to 0?
h tends to 0 means
Oh, h is
this is the
going
distance h.
closer to 0.
Yes, this is the gap h, and we are trying to h tends to 0. H is not 0. T1 is not equal to T2, but it is so close. We are trying to minimize h as much as possible. This is not a very rigorous example, but if you look other videos in YouTube, they'll give you a much more better definition of what this h is. But for practical purposes, you'll get the idea about what this is.
Yeah.
For normal ones, there is a considerable amount of distance here, but here, this distance we're trying to minimize very much.
Mm.
Okay, so yes, so this is basically what it is. We're trying to measure the rate, the instantaneous change, the rate of change. This is what differentiation is. Okay, so after that, uh, what else? Okay, and before coming to an example, I'll just now explain the similarly I'll explain the concept of integration as well. Then, if we have time, I'll give examples of photos. Is it okay?
Yeah, I can continue.
Okay. For in case of integration, suppose previously we have mentioned that velocity is equal to distance by time. Here I'll refer to here I'll refer distance as s. Okay.
Yeah,
Okay. And so this implies distance is equal to velocity into time. And suppose this is the velocity by time graph. Okay.
yeah,
Okay. Before I explain this, I'll give you the definition of integration. The integration is called as the area under the curve. Suppose we are given this line, and suppose we are asked to find out the integration of this line. So what we are trying to do is we are trying to find the area under this curve. These are all about. This is what integration is all about. And why does it make? Why does it? Why is it necessary? I'll give you with an example where we find an area of a curve, area under a curve, which is a straight line but not a curved line. Again, let us take the example of a car. Suppose this is time in hours and this velocity in kilometer per hour. So for the first 2 hours, I am driving at a speed of 30 kilometers per hour, and the next 2 hours I am driving at a suppose at a distance or at a velocity of 50 kilometers per hour. This is going to be the velocity time graph. I think so in class
yeah,
11 we studied this kind of graph. And
yeah,
now, okay, so now using this, suppose now we are going to ask that, okay, for first 2 hours, another first, no, write it down. First 2 hours we are driving at a rate of 30 kilometers per hour, and from the second to fourth hour we are driving at a speed of 50 kilometers per hour. Now we are asked to find out how much total distance we have covered. So we can use this formula twice and we can find
yeah,
it. Suppose for the first 2 hours, the velocity is 30 kilometers per hour into the time is equal to 2. For the next 2 hours, velocity is 50 kilometers per hour, again the time into 2. So 60 plus 100 is equal to 160 kilometers. This is the distance. But
yeah,
if you look at this 30 into 2, if you look geometrically, if you look at it, what are you trying, what have you calculated? 30 is the length or breadth, consider anything. This is the length, and suppose this is the breadth. This is the actually this is not the 30. This is the 30. Suppose this is the length,
yeah,
and this 2, this is the breadth. So actually
yeah,
we have calculated the area under this curve, this area of this rectangle. Similarly, 50 into 2, we have
yeah, yeah,
calculated the area here. So suppose instead of
right,
going at a constant speed, suppose a car goes at a variable speed. Suppose this is the curve. Now we are asked to find out that how much distance it has covered. So now we can't use simple formulas of rectangles. Now we need something complicated. This is
yeah,
where this is the integration. This is where we use integration to find the area under the curve. Now do you get the idea of what integration is?
yeah, I understand. Conceptually, I understand
Yes,
what is the concept.
that is the what it is. And actually, integration and differentiation are called the integration is also known as antiderivative because uh, because in case of differentiation, we had the distance and the time, and we were trying to find out the instantaneous velocity. Here we have the velocity and the time, and we are trying to find out the distance. So this is the anti of one thing. So even if you do something like just the formula, if you look at it, suppose we are giving 3x squared plus 5x, and if I ask to do differentiation of this thing, so what the answer is, I think we might remember the it is 6x plus 5.
6x plus 5.
Yes.
Yeah.
So now if someone asks you to integrate this, you will write it as 6x 1 plus 1, 1 plus 1 plus 5, x to the power 1, 6. Oh no, yes, 6x squared by 2 plus 5x plus c. So it is 3x squared plus 5x. So this comes back plus c actually constant because we don't know this it has a constant. So it comes back to the original one. So if you integrate something, if you differentiate it and then you integrate it, yeah, you come back to the same thing. So it is the anti of one another. So did you understand this part?
Yeah, I understood.
Okay, so fundamentally this is it. This is what it's all about. And in case of application, suppose in optimization kind of things, we are asked to find the maxima and minima of a graph. Suppose we have something like this and something like this, and suppose this is, so if someone if you're given the function this of this, suppose this graph is represented by some equation, something like this. May not be this, I am not sure, but suppose, and
Yeah.
this represents the time and speed. And suppose we are asked for, someone asks that which is the top speed of this. Suppose this is the uh, speed into time graph. This is the speed in time graph, and we have to find the top speed or top velocity of the car. Top, by
Yeah.
graphically, we can see that this is the top velocity. This part.
Yeah.
So at this part dx, this part the slope is 0. So for whenever we try to find out the slope or the maximum point, we keep dx by dt equal to 0. So here we will d dt of dx square plus 5x plus 6 equal to 0. So 6x plus 5 equal to 0. So we can find x equal to minus 5 by 6. Okay. If x is equal to minus 5 by 6, if you put x here, we'll find the coordinate of y as well. So we can find out the coordinate at which point in time
Yeah.
this car had means at if it was at its top speed, and what was the how much distance it had covered. So this kind of practical applications are there of.
So, but the thing is, the slope can be zero in multiple points, right?
Yes, there's something called as the local maxima and local minima. So I'm I my memory is not very sharp at the moment because it's been a while. So uh, yes, there are different ways of determining. So there
Okay.
are called local minima, local maxima, and the global maxima, global minima. Suppose this is, if it is something like that. Here also the slope is 0. Even here the slope is 0. How to find out that this is not the actual the global maximum or not the local maximum? So this kind of this yeah, the details are there, but I'm not very. I would say I forgot those things. I have to brush up those points. But there are techniques. So conceptually, this is all what in the differentiation integration is all about. So
So, what is this is like in 12th standard. Then what did you learn in engineering? What is about this multivariate calculus and all?
multivariate
What is
calculus.
the next level? What
Yeah,
is
the
the next level from this?
next level is multivariate calculus. Well, this here in univariate calculus, the polynomials are of only one variable. So
Okay.
in multivariate calculus, first of all, you have to learn about polynomials of more than one variable. Fxy, like xy square plus 2xy or something like that. And here The differentiation can be done with respect to something with one variable at a time. Suppose and a notation is notation here is different. Do you remember this kind of notations?
I remember this. Is it called? What is it called?
Partial differentiation.
Okay, yeah, yeah, partial differentiation.
Okay. So suppose when you do partial differentiation, so I would say that one of the variable, suppose if we are doing the partial differentiation of this function with respect to x, here y is considered as a constant. So here if we do this, it will be x y square plus 2y. And if we do the same function with respect to y, it will be 2yx plus 2x. So it depends on how we differentiate it with respect to right, with respect to which variable. So this is the
Right.
I would say the mathematical or the technical part. So practically, what does it make, or what this tool can be used to, I would say model what real life things. So uh, there might be a lot of things where more than one variable is, I would say, is being modeled. So one in dependent variable is dependent on maybe more than fz. One dependent variable is dependent on more than one independent variable. So x and y both influence z. So there could be many things, like suppose weather. So weather is maybe suppose z defines the temperature of the day, and suppose
Yeah,
x can be some parameter one, y can be another parameter two. It doesn't mean practically the temperature of a day doesn't depend on only one parameter. To model the temperature, suppose you're trying to focus the temperature one day from now or 1 week from now, we can't use only one variable, one dependent variable, or one variable to measure to calculate what the temperature will be 1 week from now. Many factors will play a role to determine
yeah.
the final temperature of next of maybe a week ago, week from now, or maybe a month from now. So for those kind
So
of
then, does the concept of regression depend on this multivariate calculus?
uh, I no for use for single variable regression, it has only one.
Yeah, but there are multivariable regression also.
Yes, if it's a multivariable regression, then yes, then it will probably require functions of more than one variable. Yes, yes, there are multivariate regression. Yes, I remember we studied in first semester. It didn't
Yeah,
keep exam, but it was there. So there are two things. There is multivariate regression and multiple linear regressions. So those are something. A multiple linear regression is just sequence of various linear regressions. That is similar to a uh, a polynomial with only a single variable. But if it is a multi-variable linear regression, that means it has more. That is the equation or the polynomial will have more than one variable. Yes. So okay. So for those kind of things, uh, multivariable calculus may be of will be needed.
yeah.
So yes. So that was all the I would say the essence of calculus is all about. So have you heard of the YouTube channel called Three Blue One Brown?
Yeah, I have seen a couple of videos from the channel. Yeah,
Yes. So yes. So yes, ma'am. Even the fundamentals or the conceptual basis of calculus I have learned from this video. Maybe I would say a couple of years ago during the lockdown period, I would say. So it actually may help me understand what it is all about. So far, we only knew about the calculations on how to calculate the EX
formulas
of
and all.
yes, but what it means. So there are two. He has a series of he has a series called The Essence of Calculus. So in there you can find two videos. One is the essence of derivatives, or yes, and the other is the essence of integration. So whatever I've explained here comes from his videos, and his videos explain it far more clearly. This thing.
There's also another channel called Math Sorcerer. Have you heard of it?
What did you say?
There's a channel called the Math Sorcerer.
Yes, yes, I've heard of it. Just a minute, okay. Oh, ma, pa.
Yeah,
Oh, oh, ঠিক আছে. Oh, hello. Can you hear me?
yeah,
Okay, okay. Yes, yeah. You were
yeah. I
talking
can
about
hear.
the math sorcerer.
Yeah, so yeah, I don't think he teaches maths, right? He just talks in general about mathematical concepts and
Yes,
other general topics.
yes. And he has a few courses on Udemy, and
I had seen a few of his videos, but I didn't know that.
yes, I found. But yes, yes, his video advice are useful, or I'd say he gives good advice. I've seen a few videos of his too.
Yeah,
And yes, and uh, how much time do we have? 7 minutes. So uh, if I'm talking about learning mathematics from the basics, so there, I'd say the foundations we can I can divide it as in three parts. As far as school level is concerned, we can divide it as three parts. The the first part would be, I would say that almost everyone, every adult who has gone to school will be clear with the first part. The first part, I would say from classes 1 to, or whatever the class, nursery to class 4 or 5, I would say,
yeah.
which includes
Okay.
basic number like counting, what is 1, 2, 3, 4, 5, and basic arithmetic, which includes division and multiplication. So I'm sure every adult who has gone to school is at least can at least do this much mathematics. I think we'll agree.
Yeah, yeah,
Yes. So after that, I would say from classes 5 or 6, whatever it is, from 5, 6 to class 10, I would say the four fundamental topics will be algebra, the number system, then there will be geometry, and uh, I know probability and combinatorics in India. In at least in our when we were in school, combinators. My spelling is wrong. Okay, so at least when we were in school, we had very basics of probability, and we didn't have any combinatorics. Like permutation and combination, we didn't have until class. It started in class 11. We didn't have it before
yeah.
class 11. But I think so in US and probably in other European countries, this start this thing starts earlier. I think so. And after this, in class 11 and 12, we can broadly term this most of the subjects as pre-calculus. All of those things with sets or polynomials, this coordinate geometry, trigonometry, everything apart from calculus itself, which is definitely not pre-calculus. There will be calculus, and yes, apart from that, everything else that you study in class 11 is you can term it as pre-calculus. So this is unless and until we understand these topics thoroughly. So whatever we study in university, that we are just it's just a black box for us. That we have to just take the face value and use the formulas and just solve the equations. We can't fundamentally understand what it is.
Right.
Okay, so that's why in my spare time I'm just trying to uh, make all of these fundamentals much more clear. Is, is much more clearer. So, as far as have you heard of this website called Art of Problem Solving or EOPS?
No, I've never heard. What is it about?
Yes, it is about preparation for Olympiad mathematics. So it is a US based website, so they teach them. So they have four books, each of for each of these four categories. And yes, I have those.
Okay.
And okay, maybe I don't know, these are probably illegal books. I've got through this, and if I say this on the internet, maybe you never know. Like someone will clip
Yeah,
you and show it to you doing this kind of thing. So we'll talk on the phone about this. So I'll send you these things, which we might have this. And okay, one thing I can say here is that these books are not like the textbooks that we had in school. Okay, this will, but each and every problem is solved here step by step, or it is like it's like you'll feel like you're reading a storybook here. It's written that way. And since these books are meant for students from class 5 to 10, if you read this, you won't find it difficult at all because we are way older than the the age group for which the book is supposed to be.
yeah,
So uh, your I'll send those books, and once you at least I'll send the first book. Even if this for non necessary for even the kind of exam, the aptitude exam you're preparing for. So even
yeah,
if you study or just for go through the algebra book, you'll understand things from a conceptual level. So if you are preparing the numericals from other books, it's okay because or other sources, other videos, they will give you the shortcuts on how to solve problems for from an exam point of view. But at the same time, if you learn the fundamentals of the concept,
fundamentals. Yeah,
yes, then things will become much more clear to you.
right.
So yes, so I'd say that's it. And do you have anything to say?
Yeah. Not, not really. We can end it at that.
Okay, so I can stop the recording.
Yeah, you can stop the recording.